back to the data. And the day's almost over, so. I'm going to be talking about work that began in 1975 with Mike Hoover on the study he talked about in the first talk. And we are, this little part right here, it was called Overstory Productivity in the big picture that Mike was working on. Corkscrew is pretty close to the top of its watershed, only 3 miles from Lake Trafford. This is where Maureen lives right here, and Kathleen lives up here, and get to know the place. And part of the reason the study was done here is that we were looking for setting up a baseline on data in a relatively natural system, and this was very good in terms of hydrology. So the hydrology was intact, but the fire was another, which is another big factor, was not. Ranchers, before Corkscrew purchased the property, burned whenever they could, fairly often. When Audubon purchased the property, they excluded fire starting in 1954, and so when this study began, there had been fire exclusion for 22 years, except for the occasional wildfire. So we're going to go back to the Central Marsh transect here that Mike talked about earlier, and quite a few other people have talked about. We started with our vegetation plots with 2 in each community going down the transect, starting with the pine flatwoods at the east and upper end, and then descending down into wet prairie. This is sandy soils and herbaceous vegetation, fairly open. We took a little jog off to the side to hit a hammock community with mixed hardwoods and a dense canopy. A little farther down the transect, we got to the edge cypress or pond cypress area with dense bald cypress, or pond cypress if you want to look at it that way. Grading into the old growth bald cypress area, and then back out into the Central Marsh, which was a herbaceous community like the picture on the far side there, back in 1975 when we started. So we did 2 plots in each habitat, and they were 25 by 25 meters with a nested 10 by 10 meter plot inside them. And we sampled all trees that were 3.8 centimeters or more DBH in the big plots, and then in the small plots we also added any individuals that were 1 meter tall and did basal diameters on those. So we collected additional data in the areas of the plots to develop regressions so that we could combine basal diameter and the DBH diameter readings for any individual species. Okay. There were 9 sampling periods during this period, and I actually did my thesis on the first 10 years of the study, and then Shannon Ludwig, who was the resource manager here, resampled the plots in 1999 and did his thesis on the same topic. So between the 2 of us, we're up to 24 years at this point. The 3 communities with the longest fire frequencies basically progressed in a kind of a classic successional pattern over time. Most of the species were reduced in number with each sampling, but the basal area per hectare was actually increasing for those species. And the early successional species were dropping out. The main disturbance in these communities was freezes. So what I'd like to talk about, just pull some things out of the thesis, were freezes and the effects they had on these communities, and then also talk about myrtles in the pine and wet prairie plots, and willows in the Central Marsh. So we'll start with freezes. When freezes occurred, when water levels were below ground, they were pretty devastating to the tropical species. But when we did have freezes in areas where there was standing water, they didn't show damage to the tropical species that was detectable above the normal range of mortality. There were 8 freezes during this period, but only 2 of the periods coincided with dry periods when the water was actually below ground in most of these plots. Strangler fig and pond apple were the two species that were affected by the freezes. If we look at the effects from the 1982 freeze here, it affected the hammock and both of the cypress communities. The second column lists the number of trees that were actually found in the plots, the sampling period before the freeze hit. And then the next three columns talk about different kinds of disturbances or damage that was done to these trees. Some trees actually shrunk in diameter, and this was a trend that we found through the whole study. We sampled a whole lot of trees, and very often they would shrink in diameter, and then the next year, next time we sampled, they would be dead. So it was a common enough trend that we considered that a stress. Then some of the trees, the main trunk actually died below the point at which we were saying they may not be dead completely, but the top part was dead. And then some of the trees were killed outright. And you can see that for the pond apples in the top graph, we had 3 trees that shrunk in diameter, 5 where the main stems died at measuring height, and 14 that died. So 79% of the trees were affected by this freeze, this single freeze, and only 6 were unaffected. There were 41 strangler fig in 6 plots, shown in the lower table here, and 1 shrunk in diameter, 7 had major stem dieback, and 17 died. So 61% of the figs were actually affected by the freeze. The deeper bald cypress plots, where there was a little bit of standing water, were less affected than the completely dry hammock and pond cypress sites, where very often 100% of the trees were affected. So freezes during droughts can have major effects on plant communities. Though we only sampled woody vegetation, we can assume that any freeze that's big enough or that's strong enough to kill trees is probably going to affect orchids and other tropical species as well. The difference in elevation from the average height of the average elevation in the pine down to the average elevation in the cypress is only 21 inches. So it's not a very strong gradient. So lowering the water table even an inch would have an effect on acres of tropical species. The demand for water is highest during the winter, and many people think that plants are mostly dormant in the wintertime, so lowering the water table isn't going to have very much of an effect. But hopefully these data can be used to educate, especially government officials and people that control our water levels. And if necessary, it could be used in court to show that there are detrimental effects to lowering the water table during the dry season. Okay, now I'd like to look at wax myrtle. This is a native species, but it can increase drastically if you don't have fire. So let's look at myrtle dynamics in the pines and wet prairie sites. This is the number of individuals in wax myrtles in wet prairie plot 1. And the gold bars are the number of individuals that survived since the last sampling period. The green bars indicate the number of trees that were recruited into the plot. This is the first time they appeared. And below the 0 line right here, you can see the number of trees that died indicated by the black bars. And the red lines indicate when there were fires. So that's not data. So if you look at this, you can see that we had about 70 trees when we first sampled the plot, 75, and that stayed pretty steady through 1981 when we had 40 left over that still were surviving after the last sampling period, and 40 new ones, and 13 died. Then we had a fire, and all of the wax myrtles were killed, and they didn't come back. And we had 2 fires that may have helped keep them down. So I think in that plot, you could say that fire definitely was helping to control or reduce the myrtles in the plot. This is the other wet prairie plot, and we had a lot of myrtles here. We had almost 500 in a 25 by 25 meter plot. That's a lot of myrtles. And we had fires that didn't occur till later in time, It took till 1987 to get our first fire, and 1997, 10 years later, for a second fire. The percent mortality after both fires was pretty high. It was 62% after the first fire and 82% after the second fire. But fires are not stopping, they haven't stopped recruitment in the plot. So mortality was also high even before we got fires right in here. And so I think we've got a second stressor working in this system. If you look, the bottom graph shows the hydro period, or the number of days for that year, or number of months for that year where water was above ground, on a scale of 0 to 12. So during the last 4 sampling periods, we had water higher than 9.5 months out of the year in the wet prairie plots, and that's pretty wet for wet prairie. And I think that may be part of the stressor right there. If you look at the period before that, the average hydro period was 4.75 months per year. So having a wet period may be also stressing these myrtles. And then there's a third option. These trees may have been around for a really long time. There were quite a few of them when we started the plot. And wax myrtle is a pretty short-lived species, so they may just be getting old and dying out. And that's kind of strengthened by the fact that right about here in the 80s, we've had pretty high mortality ever since then. So we've got three stressors or options going on in this one. If you look at the pine plots, we see a similar pattern in both of the plots. In this case, we have younger myrtles. We had a fire in either 1972 or 73 before we started the study, and over here. And we didn't have any myrtles in the first year, but by the second year, we were starting to get plants that were at least 1 meter tall. So it took maybe 3 or 4 years to get to that height after the fire. We had a really severe fire here in 1995. It killed almost all the pines and all of the myrtles during that fire. But the myrtle are still recruiting into the plot. And after that, in fact, they're recruiting at about the same rate they were here. We're starting to get them in after 3 years, and over here probably about 3 years too. So the pattern still exists. Again, we've got pretty high mortality here in 1991, and during that, between those 2 sampling periods was the wettest period during the whole study right here. So this is probably not a result of old myrtles, since the oldest one couldn't be much more than 15 years old. So this would lean us a little more toward thinking it was high water levels that were actually stressing the trees. So these data give us some hope that if we had more frequent fires than occurred here, we were actually trying to keep fire out of these plots during the study period early on. If we had more frequent fires, we may be able to reduce the frequency of myrtles, and especially if we can get a wet year to help us out. There's been a lot of interest, as Kathleen pointed out, in willow encroachment into marshes in South Florida. And I've got some data here to show you on what we saw. The marsh plots were herbaceous when we first started. This seems to be the only picture we have of the central marsh before. With Mike's ex-wife. It was mostly herbaceous vegetation, arrowhead, pickerelweed, and sawgrass. There were wax myrtles in there, but they were, I'm sorry, not wax myrtles, willows in there, and that was the only woody species, and they were all pretty small. They were in the small size class, so they were higher than 1 meter tall, but less than 3.8 centimeters DBH. So the The central marsh plots, or the willow plots as we refer to them, burned at least twice during a 10-year period and could have burned 4 times because we weren't able to check the other 2 times. So that's lots of burns for a deep marsh with organic soil. I think any burn boss would be very proud of this burn cycle, especially since we were trying to keep fire out. Let's see. So let's look at plot 1 here. We had a fire that may or may not have affected the plot before we started, but in 1975 we had about 81 willow in the plot. Then in March 1975, which is growing season for willow, we had another fire which managed to kill all of the willows in the plot, but we did have, this is 1 year after the fire that we were doing the sampling, we already had recruitment back in 13 individuals. They didn't make it though, they died the next year, but still you can see that recruitment is slowly occurring up until the next fire, right here, which was in January of '82, and we sampled it after 1 growing season, and it didn't kill all the willow this time. It killed 38 out of 50, so a pretty good number. Left us with 13, but just 2 years later, we're back up to 69 willows in this plot. So I guess even with 2 to 4 burns in 10 years, which is really good, basal area per hectare actually didn't change much at all. We have 0.57 meters per hectare there and 0.51 here. So even with that many burns, once the willows are established, it seems unlikely that we're going to burn them out by applying more frequent burns. It would be very difficult to do so. And it's compounded by the fact that as the willows mature and get bigger, which they have, we're going to have less sawgrass and flammable material in there to carry a fire, which will affect the willows. So these data would suggest that we're unlikely to easily reverse this trend. And it's a cautionary tale. It's fairly easy to let this slip and turn a marsh into willow, but it's going to be very, very hard to turn it back, as Kathleen pointed out. So that's some of the data from the 24-year study. We have substantially more information on species composition, growth rates, recruitment and mortality, and the dynamics of disturbance and succession too. And who knows, maybe next winter I'll be looking for volunteers from this group to see if we want to make this a 41-year study. So watch out come next fall. I'll be looking for you. And I'd like to thank all the many people who worked on this study. We've got a quarter of a century, and there were really a lot of people that did it. So thank you.
It's really interesting because they had the big cypress symposium that we go on occasion. And Jim Birch had the same thing happen actually in the prairies. They noticed that the wax myrtles, they had been burned regularly. And one particular year they burned, they came back later, they were all dead. And it turned out that the perched water evidently was below the area where they could survive, and so they died. So reinventing the wheel.
Mm-hmm. I think there's been quite a few studies that said that, hey, we can actually kill some of these exotics if we can just burn them right before it floods, but that's easier said than done. Occasionally it works out, as you can see here. So that is an important factor, because if the tree is only 6 inches down and the water comes up, it's a lot less likely to make it, hitting them for really double stress. So. And just another example of the willows, I looked at McCollom and Slough, and we had a really bad Patterson fire, wildfire. And some of the areas there, we actually burned 6 inches of peat with willows in it. And I thought, if we're ever going to get the willows with fire, this is probably the one that's going to do it. So I staked those areas and went back after a growing season, willows up to here. It's evidently taking 6 inches of the peat off the top, which will kill cypress really well. Didn't seem to kill the willows. I think maybe they're clonal. Kind of like aspen, who knows?
Gene, what time of year were those fires?
In the willow?
For the, well, either one, yeah, willows and.
In this one, they're different for each plot, so it's kind of screwy, but, the 1982 fire was in January. But for willow are growing in January.
Yeah.
And especially in February, they're blooming, so, that's a good, winter burns are a good time to hit them. And the one that we know for sure in, 1975 was in March, so another growing season burn. Yes?
Am I missing it, or is there a correlation between the water level and those fires?
Well, some of them were prescribed burns, so they're all being done during the dry season. But, you know, with sawgrass, you can burn over standing water if you've got a good standing sawgrass too. So, yeah, the fires occur during dry periods, and when the fires occur, with a drought, I think you get even more stress, and that's one of the things that happens with the mowers. So, which one?